Okay. We'll get started with the next set of teams. So my name is Chris Van Arsdale. And our class has three teams. They are rather separate projects as opposed to the first group that was all integrated. Looking at things like potential flood hazards and hazard mitigation. And the theme for these three. We'll start with project info.
Right, well, good morning, everybody. Our senior design team was presented with Agate Street and Road Convention. I am Nate Goodman.
I'm Curtis Burns.
I'm Mariah Sheeler, and we are the curb crew.
So the main objectives for our senior design course specifically were to identify local hazards in the community and then to give context to that hazard and assess it through creating a project scope and developing a solution for that hazard.
So in order to fulfill this objective, we were tasked with using the design think process, which breaks down the project into 5 main steps. First one is emphasizing with the stakeholder. In this case, it's the whole community and being able to see what kind of hazards are in place and what things could happen again. Defining, actually selecting a hazard, ideating, which is brainstorming, coming up with solutions, and then prototyping and testing is really seeing, is our solution effective and useful?
So before we could pick a hazard, we had to empathize with the Houghton community. And to do this, we took a look at the local population and the risks to safety and how transportation is affected in the area. And some major incidents that we looked at were the yearly snowfall, the Portage Lake lift bridge outage, and the 2018 Father's Day flood. So going more off the Father's Day flood, it was a 1,000-year storm event with a 500-year storm event the following weekend. It affected the central Houghton County and it overwhelmed the roadways with the amount of water that was thrown on during that time. And for Agate Street, as in here, it caused catastrophic failure of the roadway where it was unusable until it was able to be remade.
So the reason that we chose to focus on Agate Street is because it failed worse than most of the other roads around here. And the reason it failed so bad was because in combination with the steep slope and the large amount of water, the water went over the sides of the road and eroded the soil along the edges and eventually got underneath the road and washed out all of the sub base underneath, causing it to completely just collapse because there's nothing there to support it. And so the main objective of our project was to come up with some kind of solution that would prevent that kind of failure from happening again. And like we mentioned before, the main stakeholders of this project are the residents that live along Agate Street, US 41 traffic, and the Houghton community.
So looking at the current state of Agate Street, the previous work done was in 2012, there was sanitary sewer work done. And then in 2018 with FEMA funds after the flood. And with the FEMA funds, the roadway was just restored to its previous state. There wasn't any upgrades to the roads. So as you can see, the existing curb here is still poses that threat of happening again with erosion washout. It's inconsistent or non-existent in places. In that big picture, you can see that there's some erosion happening along the edge of the roadway of the asphalt, and you can see sediment is being built up on the road, so it's washing away from the edges. And in the upper right-hand corner, you can see that it's insufficient in some places at capturing the water in the roadway and the way that the water is directed, because there's no curb system in place. It's just kind of a small dip or a small hump on the road, rather than anything to really direct the water effectively into the storm sewer.
So we started our brainstorming process. We came up with 3 ideas initially. The first was curb and gutter system. we were thinking that that would just act like a wall to keep the water from going over the edges of the road. Our second idea was to repave the road with a reverse crown instead of a normal crown in the middle like the road usually has. So that would keep the water in the middle of the road instead of directing it towards the edges and washing out more soil. But along with this idea, would come ice build up in the winter and more wear and tear on the road. And then our third option was a series of trench style catch basins that would go all the way across the road. And this would catch more water and feed it into the storm sewer system, but it wouldn't necessarily the water be going over the end of the road. And those trench style catch basins would probably have to be custom made because we were thinking we would use very large ones to try to catch as much water as possible. So that might be more expensive as well.
So to better understand the specific pain points of our hazard, we decided to perform a hazard analysis where we took the varying potential failures and their effects, and we quantified them by assigning numbers to things like failure severity, probability of occurrence, and probability of detection. We would multiply them across for each possible failure, and then it would give us a risk priority number. So the highest risk priority number is going to be more concerning and more hazardous for us. And as you can see, erosion on the street edges and saturation beneath road, like Curtis talked about earlier, is going to be our biggest issue and most concerning, and not have the highest RPM number. And then to compare the possible failures with the design options we just talked about, we reassessed the hazards using the modifications and quantified them in the same type of way. And as you can see in the yellow, we have the new RPM numbers, and we can compare them to the ones in the previous slide. And the curb and gutter system did the best job at lowering those risk priority numbers when compared to the other modifications where some of the risk priority numbers either increased or didn't change at all.
Well, after this comparison, the curb and gutter system proved to be the most effective way to be able to reduce and mitigate this event from happening again. Adding curb and gutter on both sides of the road would strengthen the roadway both by the use of concrete, but at the same time just keeping the water away from the edges and keeping it on the road surface itself. There's many different types of curb systems out there. We decided to use a barrier style curb system to have the most effect for our calculations, to have a higher wall on both sides of the road to be able to once again make sure that the water doesn't move on both sides.
So then we moved into prototyping our design. First, we used AutoCAD Civil 3D to make the cross section of the road. So we took an existing cross section from plans provided by UP engineers and architects from the sanitary sewer work they did. And we found a typical cross section of Agus Street. So then we took it and drew it again in Civil Autodesk, AutoCAD, and added the curve systems in there. So you can see a visual of the cross section. And then also we were provided with the sanitary sewer profiles for the road. So then what we did, since there wasn't the pipe system in the file that we received, we just had to cross-reference it with the plan view on top of where the storm sewer manholes and inlets were located, and then put them at the elevation that they were assumed to be. So those would have to be field checked if going forward, if they were going to do this project, they'd have to field check those locations and elevations, but that's our best estimate of where all the manholes are. And then from the 2D profile of the road, a 3D model was made in NX. So that picture, there's just a typical cross section. You can see the curb system on the edges. And then we modeled the storm sewer system underneath the road from 7th Avenue to College Ave. You can see a bottom view of it along the top of the screen. And then the whole roadway in the middle of the screen. And then that's just an exploited view of one of the storm sewer systems.
So after modeling the roadway and just prototyping it. We wanted to bring the Father's Day flood back into our calculations to be able to really see, is this gonna be effective, design to be able to prevent this kind of catastrophic failure from happening again? From the Father's Day flood, we were able to see between the hours of midnight and 6 a.m. about 5.5 inches of water fell that day. And through that data and through numbers produced by the National Weather Service, we were able to come up with stormwater runoff specifically for the roadway. So these are years and the amount of flow that you would see on the roadway based on a yearly stormfall. So once again, the Father's Day flood was 1,000 year and the following weekend was a 500 year.
Go on, get back.
To get a good idea of what the street currently can handle, we decided to use the Manning's equation and treat cross sections of the road as an open channel using steady state flow. And we calculated the flow for the minimum and maximum, which was at a slope of 1.1% and 13.6%. And that was largely at the base of the road and was the top of the road. And then when we compare that with our proposed curve solution, you can see that the flow increases quite a bit. And if you're looking at the parameters we used in the Manning's equation, we used the basic geometry of the cross section using a 6-inch curve and also a 1 1/4 inch bump on the side of the current existing road. And as you can see, the total cross-sectional area increases quite a bit, as well as the hydraulic radius, and that's what's causing the biggest increase in the flow. And it's also important to note that when we did the stormwater runoff calculations, we only did the calculations based off of the rainwater hitting the road. It doesn't account for any side streets water inlet or any runoff from lawns and houses and things like that.
Okay, so we're saying that our total price for this project would be around $132,000. The majority of that cost being associated with removal and demolition and material cost, including placement. And for the material cost, we called Baco and got a price from them. They just gave us a per foot price for material and placement. And for the schedule, we're saying that this project will take 6 weeks. We have 4 weeks in actual construction time and a week at the beginning for site prep and a week at the end for any delays or cleanup.
So ultimately, we chose this design option because it better directed the flow and strengthened the sides of the road, and ultimately helped our project design scope and fulfilled those parameters by making sure that there wouldn't be any more erosion and subsequent saturation underneath the road. It also was a cheaper option because it's most common and it would be easy to tie into the existing stormwater sewer system that we have going on.
And it's important to note that our design, it doesn't, the storm sewer system is still the same one that's in place, so there is a possibility of it flooding over if there is a big rain event again, but a benefit of the curve is that it keeps the water on the road rather than going over and washing out the sides of the road, which is what it did previously.
Thank you for listening. Any questions?
So, yeah, I was just wondering, does your system involve installing the curbs in the existing asphalt, or does the whole road need to be taken up as well, the asphalt that currently exists on Agate Street?
We remove the edges, saw cut the edges and place it.
Okay, so the cost analysis keeps part of the asphalt in place, just the edges are demoed.
Yeah, the road was just repaved.
Right.
In 2018, so it would make sense to redo the entire road.
Right,
So
okay,
this mainly has to do with just cutting off the little hump.
Yeah.
If there is a hump, I mean, it's like,
and just making the curbs more consistent.
exactly.
Okay.
So have you put any consideration into the amount of runoff that the bottom of Agate Street at College Avenue might experience through this design that you've chosen?
Yeah, we kind of thought about that as well as we started to create more and more flow on the roadway as we pushing it more down. Even though that is, an issue farther down the line, our main scope of this project was to make sure that Agate Street was still going to be there at the end of the day. Something like the Father's Day flood where you have 30+ residential homes not able to get out and go get, help is a bigger factor that we saw for our scope of the project than pushing water down onto College Avenue. They just redid College Avenue. We have no idea what the storm system that they installed like during that process, but that would be something to research further if this project were to be taken on.
Yeah, and to look at the current state of Agus Street right now, so one benefit of the curb and gutter system is it directs the water better towards the edges and into the system. So as you can see, it floods at the bottom because it's not encapsulating the water at the places it should be, and it's just flowing all the way down to the end of the road. So with the curb and gutter, it'll be better directed into the storm sewer system for average rain events and stuff. It's still a possibility that the whole storm sewer system will flood in the event of like a 1,000-year storm, but that would happen anyways with this one. But in normal rain events, it should better capture the water that's on the road and prevent flooding down the street.
This is just a comment. I was told by one of our former instructors who lives on Agate that the flow down the side streets was an issue. Like historically, before it was built as a road, it would have been like a ravine going down the hill. And so one issue is that the flow coming from the side streets sort of carved out, at the bends and started to undercut the pavement. So just thinking that maybe the curb might need to be extended, kind of wrapped around to go up those side streets and keep the flow on the pavement.
How does that affect snow removal?
I would assume that the snow removal, they would do it the same. I would hope that the plows wouldn't affect the curb, like chipping it away and eroding it as I think, but. there's a consideration.
I mean, it's similar to every other road in Houghton. There are other roads that have curbs. It's not unheard of to see a road with curbs. So, blaming snow removal or that the curb affects snow removal is kind of very minor. If you were to say like catastrophic failure versus snow removal.
What becomes what becomes your or this points of failure of this? Like if this does fail, does this become more catastrophic or? Yeah, so if the curb is now keeping more water on the road, what becomes the next point of failure? If it can't get out of the curb to erode underneath?
Yes,
This is the
so
wear and tear.
yes.
Or potholes and stuff like that, just from having more water on the road. So that could be a failure mode. Okay.
Yeah, and if there is a lot of flow going down to the road, it could affect US 41, but it's also much flatter there, and I feel like the water has a better chance of dispersing, especially with the new system that they just put in.
Yeah, so there is a greater chance of wear and tear on the road if there is like flood events like that happening. It'll create more cracks and stuff in the road, which will have to be monitored because some cracks in the asphalt can also lead to seepage underneath the road. So the pavement will just have to be monitored and like inspected to see if it needs to be upgraded, because it might have to get upgraded sooner than it does now because of the amount of water that is going to be added to the roadway.
Would keeping like you're with the improved curb and stuff, like let's just say like if the storm sewers are like clogged or something in the winter and the water has nowhere to go but to stay on the road, do you see like ice formation being an issue in the winter time?
I think if the system were to get clogged and there was ice formation, I don't think it would be necessarily due to the curb design. I think it would just be more than that. Because we're not really changing the storm system as it is.
You're creating a joint between the new curb and the existing pavement. How are you going to deal with that so there's no erosion of that joint?
Could be
These guys are brutal.
as it's installed. Or after, not as it's installed, but after. Obviously, security. You'll see it.
So you had noted in your design thinking process that the first step is empathizing with stakeholders and kind of figuring out what they want out of the situation. Have you gotten any feedback from Agate Street residents on what they enjoy about this, what they don't like about this, or?
Well, we've heard from just, general college students that live on Agate Street that this problem does occur quite frequently. We've heard from other teachers as well, other teachers and professors that, complain about the situation, but complaints aren't enough. Instead, it's more like data and proof to be able to show that, like, is this actually an important thing? It has been done on other places in Houghton, adding a curb system to try to see if this does help, prevent future failures or future flooding. The Dodgeville Street had a curb introduced onto it. I don't know if there's enough data yet to prove that, but this is once again, like, we're talking about the steepest hill in the Houghton area. So, and it's very infamous because of how many people live off of this road, and it's significantly traveled on almost as closely as US 41. So it's just, well, not as much as US 41, obviously not the same amount of traffic, but is used quite frequently. So that's why we chose this road in particular. All right, thank you.